Welcome back. So in this module, we're going to take a look at the basic programming principles in R. Now we're going to get started first by looking at some basic R programming concepts that you need to kind of get started understanding the framework, the language, some of the basic language constructs, things like how to create variables, functions, start an environment, and so on. I'm assuming that you have had a chance to review the previous lesson that taught you how to install R and RStudio. In this lesson, we're going to limit ourselves to looking only at the R IDE, the command line interface. We're not going to take a look at RStudio until a little bit later. Now, the basic objectives for this lesson are that we're hoping that after completing this lesson, you're able to manipulate objects in R, create one very specific type of object and use it, namely data frames, organize code with some simple functions, perform logical queries on data sets, detect and eliminate missing values, calculate summary statistics, and practice with some of the built-in data sets that are available through R. Now, we're not going to go and dive heavily at all into the statistical aspects of R. Really, R is meant for statistical programming environment, but that really is taught in a different course. We're going to focus on those concepts of R that allow you to collect, store, and retrieve information that you're eventually going to use to do more elaborate statistical analysis, machine learning, predictive modeling, and visualization. Now, in R, data is primarily stored as objects. Now, objects are created through one of several mechanisms, either by reading data from a file, some kind of an external file, retrieving data through a URL from a website, creating an object directly from the command line, or instantiating an object from within a program. To create an object directly is actually pretty straightforward. You do really nothing more than assign a value of some sort to an object that you make up. R is pretty forgiving in terms of declaring variables. Most other programming languages like Java and C++ and C and so forth, they force you to first declare a variable, state a type for that variable, and only then are you able to use that data. R is a lot more straightforward. R basically allows you to just simply use a variable just simply start using it, assign a value to it, and the data type is inferred by R by the type of value that you've assigned to that variable. So in this case right here, we have X and we assign a value of 99 to X. We use the greater than dash sign to indicate that a value gets inserted into or moved into a variable, into an object. The name of the object is X and the value that we're going to insert there is 99. That of course means that R automatically presumes that the type of that object is now going to be some kind of a numeric value, some kind of a number. Now this part right here is actually not typed in. This is actually the prompt that R provides. In fact, let's go take a look at that. I encourage you, as you're watching these videos and as you're working through the tutorials and the video lectures, that you actually start up R and follow along. Pause the video on each slide and then try out the corresponding commands in R. Look to see what R does. Look to see what kind of responses you get. And if you don't get the right response, observe the error message you're getting and then try to figure out what exactly went wrong. So let me go ahead and start R, and you may want to do the same thing. I want to pause the video at this point in time and go and follow along. So I've started R. In fact, I started the 64-bit version on Windows, although the other platforms like Mac and Linux look very, very similar. It normally comes up with the R console here. I'm actually going to maximize that window. I'm just going to use that one console, and I also ended up actually changing the font size a little bit larger. So it's a bit easier for you to read this. But, here's the idea that, we're assigning a value of 99 to that object. There it is. There's really no response you're going to get from this. But if you then type in just the object name, the identifier by itself, it's going to then print out or respond with the value of that object. Now in R, there's really no such thing as variables. They're actually all objects, if you will. One of the things that's kind of interesting is that there are some very specific conventions for naming objects, but we're going to talk about that a little bit later on. Now, objects in R are case sensitive, which means that R treats the object names AP in all uppercase and AP in lowercase as different objects. For example, if I typed in R capital X, it would not know what the object is. It says object X, but the capital X is not known because I assigned the value of 99 to the object with a lowercase x. So be very careful about the way that you type your object names and make sure that you watch the capitalization. Now, when you access files, I would also recommend that you try to distinguish between uppercase and lowercase letters. For example, airpassengers.txt in A and P being uppercase and airpassengers are lowercase are actually considered two different files. Although in practice, some operating systems don't care. For example, on Windows is case aware. It stores the file with the right case, but it actually does not use the case when it retrieves files. In other words, it's not case sensitive, but it's case aware. When you write larger programs eventually in R, and we're going to get into a lot of larger programs a little bit later on, you want to organize your code with functions. A function is a chunk of code that you can use as a single unit. So for example, right here, I'm defining the function called fraction. So let's go take a closer look at this. What I've got right here, and this part right here, is the function fraction. I know it's a function because I used the keyword function. And notice that particular pattern that we use here. Function name with the assignment, followed by the keyword function, followed in parentheses by parameters to the function, and then followed with a curly brace. This curly brace here is very important. That actually starts the function, and then this ends the function. Now, once you've done that, you've actually defined another object, a function object in this case, called fraction, that results in a computation. And inside the computation, we take the input variables x and y, we divide x by y, we take that value and assign it to a new variable called result. And then we print out the result using one of the built-in functions called print. And that's it. So now if you call fraction from the command line and you pass it 3 and 2, it's going to go ahead and make, let me just show you what this looks like. Let me just erase this there for a second. All right. So now what's going to happen here is that this value 3 gets passed in as x, this value 2 gets passed in as y. So now within the function fraction, x is equal to 3 and y is equal to 2. So when you refer to x over here, you're referring to the value 3 that was passed in, and with y, you're referring to the value 2. Result then is x divided by y, which is 1.5, and that's the result gets printed out using the print function. Now we'll talk a lot more about functions and function organization later on, but it's a very powerful way of helping you build reusable code. Arrays are another important part of R and another type of object. An array is created as a concatenation of values. There is a built-in function called C, which stands for concatenate, that takes multiple values and puts them together, concatenates them together. So here we got A, and A is now assigned the value 1, 2, 3, 4, 5 as an array. In fact, if you print out A, you get multiple values. Now what's interesting is in R you can actually do direct array manipulation. You can add 10 to an array, which means you actually add 10 to every single value within the array. You can print out the array. You can create a new array from an existing array with an operation to it. So that actually takes A, divides every single element by 2, and assigns that new array to the new array value B. And then you can print out B. You can add two arrays together, A and B, which adds every single one of the members with the other member. So it's a very straightforward mechanism for building arrays or sort of strings of values. Now to figure out all of the objects that in your current R session, all you have to use is ls. Let me show you what that looks like. If I type in ls, I get all the objects that I have in my current session, which is just, of course, in this case, x. To remove an object, you use rm. Of course, if you assign a new value to the same object, it's going to get overwritten with a new value. But if you don't want an object anymore, perhaps because it uses too much storage, you just want to make sure it's not getting saved anywhere, or it doesn't cause any confusion with another object, you simply use rm. So for example, rmx would remove the object x. If you do a list now, it's no longer there. To delete all the objects in your session, you can use this mechanism, rm list equal ls. That creates a list of all the objects with ls, assigns it to a list, and we're passing that to rm. That essentially removes all the objects being sent to it by a vector. Now, comments are another very important part of R. Longer scripts, when you write them, should be commented so that you or others understand the intent of the commands and the functions. And in R, any text after a hash mark is ignored by R. So for example, if I write create a new object with an initial value of 25 with a hash mark in front of it, that's completely ignored. For example, if I do this, it doesn't matter what I type, it's completely ignored. So that allows you to comment your scripts, and when you then save them or copy them or reuse them later on, you know exactly what each line in the R script did. It's also very important when you submit assignments to us. We want you to use comments because we want to know what your intent is. We want to know how to read your code, and if you don't provide any comments, we really don't know how to read your code. We don't understand what the code is supposed to do or what you intended the code to do. So to summarize, in this lesson you learned that in R, variables are called objects, that object names are case sensitive, that functions help you organize reusable code, and that comments are very helpful in explaining what a script does.